questions. Okay, for those of you listening at home, hey Michael, we're here. We're giving out the last new notes of the year, and it has to do with finding coefficients. Like if I raise like a plus b to the 50th power, now that's going to be enormous. This is going to be 51 terms. And the numbers are going to be huge. If you carry, you'd have to carry out Pascal's triangle with the 51st row, and wow, I mean, first of all, it takes a lot of paper, and the numbers are going to be like 5, 6, 7 digits long, for all we know. So, and what if I only wanted one coefficient? What if I want the 30th term? And that's all I wanted. Do I have to write out the entire thing? That was a question that Blaise Pascal and his pen pal were tossing around. It turns out the answer is no. There is a way to get it directly, just by itself. But I have to take a complete U-turn and talk about something that's seemingly unrelated to this for like 10 minutes. It's fun in and of itself, but write down the numbers 1, 2, 3, 4, and 5. How many different orders can you make with these things? How many different ways can you rearrange them? Any ideas? A good guess. Okay, well, let's start with something smaller. 1, 2, 3. How many different ways can you rearrange them? Like, how many different orders? Let's assume there's 3 people. And I say, person 1 in front, or person 2 can be in front, or person 3 can be in front. How many different rearrangements can you make that would be different? What's that? Maybe 3. Let's list them. 1, 2, 3 is the easiest. 2, 3, 1. 3, oh, well, okay. Well, I'll tell you what. There's a bit of a danger here. We might miss one if we start jumping around. List all the ones where 1 is in the first spot. There are only 2 possible. There's 1, 2, 3, and 1, 3, 2. Does that make sense? This is, everybody know what an odometer is? It took a long time for me to know. The odometer is the thing that keeps track of how many miles you drove on your car. That thing that clicks up, it's like you're like 100,000 miles or something like that. That's the odometer. The odometer trick is that you let the right-hand one, you know, the one on the right spins the fastest. It goes through tenths of a mile, and then it clicks to a 1 mile, and then the miles click to 10 miles, and the 10 miles click to 100. So eventually you start getting moving. But this one changes the fastest, then this one next, and then this one next. The odometer trick for listing things is change the right-hand side the fastest, then change this, then change this. Now start with 2. Give me a list of any possibilities. Yeah, 2, and do them in order if you can. 2, 1, 3, and then the other one is 2, 3, 1. Good. Start with small, go to big. Now, how about any other possibilities? Yeah, starting with 3. 3, 1, 2. How many different arrangements did you get? There's 6. Interesting. Is there a way to figure out how many rearrangements? Turns out, yeah. Let's start with A, B, C, and D. I'm going to list them over here. Just you don't have to write these unless you want to. I'm going to try the odometer trick. I'm going to do A, B, C, D. And then I'm going to switch these. A, B, D, C. Does that make sense? So I'm going to change the right-hand ones first until I have no other options. Then I'll start changing these. So I start with A and B and let these flip. The next possible option is A and what? A, C. options there. BD, and then there's one other, AC, DB. See how that works? What would the next category be? AD. And then what are the two little ones? Yeah, BC, and then AD, CB. Looks like we've run out of options for A being the leader. Anybody have a shortcut? Yeah. How do you get 24? Six of them are starting with A, and then we ran out. Guess how many start with B? 6. Guess how many start with C? Exactly. 6, 6, 6, 6. And then blah, 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 24. Blaise Pascal and his pen pal were trying to figure this thing out. And they said, is there a way to find out the total number of rearrangements ahead of time? Like, what if there were 10 people? Is there a way to find it out? Well, listing them would be a nightmare. Turns out the answer is yes. How did we get 24? 4 times 3 times 2 times 1. Guess how they get 6? 3 times 2 times 1. What if you had 5 letters? 5 times 4 times 3 times 2 times 1. Bingo. And you just discovered a very obscure thing. The notation is kind of funny. But if you have 4 numbers, then the total rearrangements are 4 times 3 times 2 times 1, which they're going to write as 4 with an exclamation point after. This thing is called factorial. Sorry, I'm writing it slanted. Factorial. Factorial just means take that number and multiply it by all the numbers less than it. 2 catches on that. First, you have to start with the whole number. Second, don't go all the way down to 0. Let me see why you don't go down to 0. Yeah, you're going to kill absolutely every answer you get. Wow, I keep getting 0 and all that. Yeah, that's because you went too far. So, does everybody have a calculator? Or no? I have some. I have one if you need to borrow one. Grab a calculator. I want to show you this. Partially because factorials are fun, but they but they get very big, very fast. They sometimes go faster than exponentials. For example, I want to know what 10 factorial is. On your calculator, it's kind of hard to find, depending on what calculator you have. If you have a graphing calculator, look for a key called math, which is totally funny because the whole thing is math. But it's math, and then in your calculator, there's going to be 4 columns on the top. One of them should say PRB. Use the arrow key and go over to it. Look at choice 4. There should be an exclamation point there. Okay, for the people who for people with the TI-30, there should, let me get my glasses. I think I can find it. There is blah 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 blah. Is there math keys? Oh, fluffernutters. Hang on a second. It might be under stat. No, not really. Come on. Well, stat variable data. No. I honestly don't know where it is. I know where it is on the graphing calculator. Did you find it? PR. Where'd you find PRB? Oh, you have a PR. Oh my goodness. I'm an idiot, yes. PRB. That's too funny, it was right in front of my face, thank you. And then the third column over is factorial, then hit enter. Now, what you have to do is you type the number first. You type 10, and then find the factorial key. So in your case, PRB, or in your case, math PRB. And then scoot over and get that. Tell me what you got. It's fairly big. Yeah. 10 factorial is 3,628,800. It's pretty big. So it's basically 10 times 9 times 8 times 7 times 6, all the way down to 1. Which you could do by hand if you had to, but it's a lot faster if you don't. Now, the Blaise Pascal and his pen pal. But I should probably give you the name of his pen pal. So Blaise Pascal and Pierre de Fermat, E-T at the end is silent. They were exchanging letters back and forth talking about probability. Can you estimate the chances of something happening? We were talking about this yesterday. Where is it possible to calculate the odds of, let's say you have dice, 6 sides on each, normal dice anyway. I'm not talking about like Dungeons and Dragons dice, but when they have like 20 sides. But if you have regular dice, and yet let's say 2 of them, what's the chances of throwing double 6s? Let's check. A 6 and a 6. What are the chances of throwing that? It's not very easy to do. It's possible. What's the chances of rolling a single 6 with 1 die? Was it? How many sides on the die? 6. It's kind of like a box. So it'd be 1 out of 6. Very good. The numbers are 1, 2, 3, 4, 5, and 6. Does it make sense that 1 out of 6 would be the odds or chances? Right? What's the chances of rolling a 6 on the other die by itself? 1 out of 6. What do you do with the 2 fractions if you want to combine them? Remember yesterday? Multiply them. The chances of rolling a double 6 is 1 out of 36. Which is possible. Basically, you'd have to play the game 36 times in order to win once on the average. Which, by the way, is not guaranteed. If you're ever into probability, one of the things that hooked me into studying probability when I was in college was the question, well, let's just say you're throwing dice. Let's say you throw a pair of dice 36 times. Is it guaranteed to come up a double 6 sometime? No. So the question is, what's the probability of having at least one double 6 come up? That's a pretty deep question. Kind of like, there is an answer to it, by the way, but go study it in college. It's totally fun. Where was I? All right. Now, let's get down and nerdy. What you just played with, the number of arrangements, we were calling it the number of arrangements. There's a technical math word for this. They're called permutations. And this is kind of from the Latin, per means through, and mutation means to mute, to change. So to change through. So you're changing the order over and over and over and counting all the ways you can do that. So all the number of permutations, if you have n items, then you would have n factorial permutations. So if you have 5 items, it's 5 factorial different arrangements of permutations. 5 times 4 times 3 times 2 times 1. Okay. Now, so if we, like 4 of us, we say, how many different ways can we line up for the fire drill? First of all, you don't go out through all the permutations for a fire drill. You burn up and die. So you just take go. But how many different ways would there be? Calculate in your head. How do you get that? 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. So there's 24 different ways the four of us could arrange ourselves in the line. Which is kind of interesting. Like, wow, that's a lot of different ways. What if we started changing things up? Suppose I have 10 possible players. Let's say volleyball. And you need to pick 6. How many ways? Can you pick them? Now this is a different question than we're asking before. If you have 10 possible players and you have to pick 6, I mean, normally what we do is we rotate them in. But how do you pick the first 6? How many different ways can you do that? Does it matter what order the 6 people come in? No, not really. I mean, on the volleyball floor, maybe you want somebody serving first, but pretend they're all pretty skilled. How many different ways can you pick 6? It doesn't matter the order. You know, well, I have Bill first and then Sally next, or Sally first, Bill next, who cares? I just want to know how many different groups of 6 can you pull out of there. Well, let's try a smaller version. Let's assume you have A, B, C, D, and I want to pick 2. How many different ways can you pick 2 people? Let's list them. What's the very first option? A. If you do them in order. A, B. So person A, person B. Do I have to count BA? No, it'd be the same group of people. It doesn't matter what order they're in. It's kind of like saying, I'm picking 2 people to ride in my car. It does not matter what order I pick them. They both can ride in the car. Give me another pair. AC, very good. AD, good. That's using the odometer trick. That's all the possible ones with A. Now I don't have to do BA. What's the next option? BC. You could also do BD. We've just run out of options. This ran out a lot faster than the other one because we don't have to count all the different arrangements. A, B, and BA are not 2 different things. Like, if you're putting them in order, let me give an example. Let's assume we're giving, let's say there are 10 people, and 4 people are being chosen to go to Washington, D.C. Does it matter what order they're in? No. Now pretend out of the 10 people, 4 people are being chosen for prizes. First prize, second prize, third prize, fourth prize. Does it matter what order now? Yes, it does. If the order matters, permutations. My old high school math teacher, God rest his soul, helped me out with that. If placement matters, then you use permutation, P for P. I haven't given you the second word yet. What do you call this if order doesn't matter, if you're just choosing people? This is called combinations. Where the order doesn't matter. And combinations almost always deal with taking a small group out of a bigger group. Otherwise it'd be a pretty dumb problem. If you have 10 people, how many different ways can you pull all 10 people? 1. Okay, all 10 of you? Come on. That was easy. In other words, if you have 10 people and you can only pick 6, how many different ways can you do that? Well, how did this work? We started with 4. Let's just say n is equal to 4. N is the number of possible things to choose, or people to choose. And we picked 2. So basically, I'm going to introduce you to 2 letters. N is the number of possible choices the letter R is the number actually chosen. And R cannot be bigger than N, obviously. You can't have 10 people and choose 11. Doesn't make any sense. So what we did with permutation, I'll do that in a second, but combination looks like this. They write it like this, NCR. So they'd start with the number you have total, then C for combination, and then R is how many you're actually going to pick. So this particular case is 4C2. How do you do it? Well, interestingly enough, I shouldn't tell you this, but go to the PRB menu, or the math PRB. You just remember where we found the factorial? Look to the left of that. Or in your case, look a little bit further up. Do you see NCR anywhere? Interesting. Hit clear for now. What you're going to have to do on a calculator is you're going to have to type this first. Type the N first, the number. Then type NCR, so go to that menu. And then you're going to type R. So in this case, you'd have to type the number 4, then do the menu thing, then type the number 2. And just for fun, go ahead and do it. So NBR, fluffer notice, I forgot to type 4 first. So type 4, then do PRB NCR, and then 2, yeah, I got 6. Oh, good. That's exactly what we got. How do you do it? Well, I could just leave it a mystery. I will give you the formula. NCR is equal to n factorial, which is the original thing we were playing with, over n minus r factorial times r factorial. Now you don't really need to know that for this class. I'm not testing you on it, by the way. Well, I'll think about it. For now, that might make a great extra credit question. But, let's try another one. You have 10 possible players, pick 6. Tell me the answer. You got it? Darn it. Okay, 10, hold on, I gotta catch up. 6. Have we got it? What does your calculator say? Oh, type the number 10 first, and then go to the PRB key, and it's NCR. Then after that, type the number 6 and hit enter. What do you get? 210? 210? What do you get? Oh, let me see. And then type the number 6. Bingo. It is 210. There are 210 possible ways to pick 6 people out of 10. Right. Now, why do we care? Actually, I might have a bit of a semi-pleasant surprise for you. There are only 7 more minutes in class. There is no way in God's green earth I could finish the notes for the homework. I guess you finished your last homework today. Congratulations. But I do want to show you how to do this in the 7 more minutes. What does NCR have to do with what we were doing yesterday? Excellent question. I'm going to expand out, so 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5. I'm not going to go too far here. 10, 10, 5, 1. Question. This is the row with a plus b to the, this is to the 0 power, 1st power, 2nd power, 3rd power, 4th power, 5th power. Let's assume I want the 3rd term coefficient. Let's just say, whatever the third term is, I want the coefficient. Now we know it's 10. But if I crank this up to 100, a plus b to the 100th power, and give me the 21st term, we do not want to do this by hand, unless you're really into self-abuse. Do me a favor. We've got a 5. Type this in. 5 NCR. Go ahead and try that. Type the 5, then do the NCR. I want you to experiment. Can you find a number? You can't go above 5, by the way. Can you find a number to type in there that would actually give it? Try 5 NCR 0. What do you get? 1. Explain what just happened. What are they asking for? Like, what does this mean? Think you have a bunch of people. How many people do you have standing around? 5. How many people do you want to pick? 0. How many ways can you pick 0 people? 1. Just say, everybody stay. That's the only way. Now try 5 NCR 1. What do you get? Any guesses? 5. Does that make sense? There are 5 different ways to pick one person. You, or you, or you, or you, or you. Try 5 NCR 2. Really? Try 5 NCR 3. What do you get? Try 5 NCR 4. I don't know. What do you get? And try 5 NCR 5, just for snorts and giggles. What do you get? Well, I'll be damned. You just got 1, 5, 10, 10, 5, 1. Thank you, Blaise Pascal. This is 5 NCR 0, 5 NCR 1, and so on. So what we want is 5 NCR 2. Now the only thing, whatever term you want, you just do -1. The reason is because we're kind of starting from 0. So I'm going to do a massive question for you. But now you have the power to do it. Suppose you have a plus b to the 100th power. And I want the coefficient of the 33rd term. Any ideas how to do it? What would you type? What do you think? What would be your first number? 100. NCR. 32. Now be prepared for a big number. 100. I gotta catch up. NCR 2. It probably got so huge that it kicks into scientific notation. Yeah, I got it's approximately 1.4301 times 10 to the 26th power. Glad I didn't carry that number out, and all you have to do is carry this Pascal's triangle out to 101 rows. This is going to be your 33rd coefficient. A 1 followed by 26 zeros. I did try and write this on paper. You first. So, does that make sense? But that's it. That's the coefficient. And by the way, I can give you the term. I mean, this is approximate, sorry. 1.4301 times 10 to the 26th. Question. The very, very, very first term. What's the power of A? Or in this case, the very, very first one, before you start counting along. It'd be A to the what? 100. And B to the what? 0. That's the first term. This first term is basically blah, 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 a to the, like, I'll do the small one, a to the 5th power, b to the 0. The next one, so this is 5 NCR 0, that, plus 5 NCR 1, a to the 4th, b to the 1st, plus 5 NCR 2, a to the 3rd, b to the 2nd. There's something funny going on here. The number in the last number in your coefficient and the power of b are always the same. Now, that's a funny thing. If you're on the 3rd term, this is always -1. I now know that this is a to the something, b to the 32. Because that's the number I was using. Can anybody tell me what the power of a has to be? There's a sneaky little trick here. Like if this is a to the 3rd, b to the 2nd, what's the trick for that? What do they always have to add up to be? 5. These have to add up to what? 100. Anybody want to take a shot at it? You just got the 33rd term of a monster binomial expansion. Congratulations. It's actually kind of a college level problem. Pat yourself on the back. Questions? This could be, I will post this on YouTube, so Michael, you got a fair shot at it. This could be a great extra credit question. We'll see what happens. But if you see it on the back page, just say, is Mr. Cochran smoking something? No, I'm not. First of all, don't do drugs. Second, except math. Math is the only legal drug, right, as far as I'm concerned. The second is, this is an extra credit possibility, and you now have the key for it. And that's all the time we have. Please stand. In the name of the Father, the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. Last little plug, by the way, in college, if you take a class called Advanced Probability, you can study the couple of these things for combinations. Somebody asked the question, flip a coin 100 times. What's the probability that you get exactly 72 heads and exactly 28 tails? You can use this to find out. You might ask, yeah, who cares? Can't answer that. Cheerio, y'all. Thank you, and see y'all later, Michael. Hope you feel better or wherever you are.